lovely students. Well, I am away at the Kairos retreat. We're trying an experiment of me putting a lesson on video, and then you'll come in and work on the problem. So we're doing section 4.5, solving quadratic equations by finding square roots. So really, finding square roots, some people might consider this to really be the only way that you can solve a quadratic equation, other ways being derivatives of this. But let's just kind of go forward. So first of all, let's just remember what a square root is. So when I have a square root, I use a radical sign and I put a number underneath it, in this case 4. And a square root sign is asking me the question. It's saying, what number times itself is going to give me 4? It's going to give me the number under the radical sign. Well, 2 times itself is going to give me 4, and negative 2 times itself is going to give me 4. That's kind of, kind of going back to pre-algebra a little bit, but sometimes it helps to remember what it is exactly we're asking for when we get a square root. There are important terms you need to know so that we can talk the same language. That is called a radical sign. The number underneath the radical sign is called the radicand. And sometimes you'll see a little number up here, like a 3 or a 4 or a 5. When there is no number there, when it is blank, we assume it's a 2, and that we're asking for a square root. But sometimes it is a different number, like a 3 or a 4. And that number is called the index. So 3 terms you need to know: radical sign, radicand, and index. There are some very important properties of square roots that we need to know. Product property and the quotient property. So what the product property says is that when I have radical AB, which is of course the same thing as radical A times B, times, not plus, that is the same thing as radical A times radical B. Let's just do a quick example of that. Kind of a straightforward example would be radical 4 times 9, which is equal to radical 4 times radical 9, which is equal to 2 times 3, which is equal to 6, which we could have seen by doing radical 4 times 9 equals radical 36, and we know that the square root of 36 is, in fact, 6. But it's just kind of a very straightforward example of what we're doing. It's radical A times B. This would not work, so don't make this mistake. Radical 4 plus 9 is not equal to radical 4 plus radical 9. Think about it. Radical 4 plus radical 9 would be 2 plus 3, which is 5. But radical 4 plus 9 is equal to radical 13, which is certainly not 5. The square root of 13 is certainly not 5, because 5 times itself is 25, not 13. So be careful when you're doing the product property. It is called the product property because this is a product. It's a multiplication sign, not an addition sign. The quotient property is very similar. If I have a radical sign over a fraction, I can divide it up into radical A over radical B. This is very helpful sometimes, particularly if A or B is a perfect square, and I want to not have a radical sign in my denominator. And that's going to be an important point here, because we do not want to give expressions that have a denominator with a radical sign in it. And getting rid of the radical sign in a denominator is called simplifying or rationalizing a square root. So here are some examples. These are right from the book. But let's take a look at A. Radical 80. Well, I can turn radical 80 into radical 16 times 5. Well, that's equal to radical 16 times radical 5. And the reason I picked 16 is because it's a perfect square. So that is equal to 4 times radical 5. And that's our answer right there. We have simplified the radical. You always want to pull out of the radicand, any factor that is a perfect square. Let's take a look at the next example. Instead of having it under one radical sign, I have two of them combined. Radical 6 times radical 21. Well, I can combine those to make radical 126. Well, 126 is equal to 9 times 14. That's equal to radical 9 times radical 14, which is equal to 3 times radical 14. Now, of course, I knew that 126 was 9 times 14 because I'm sitting here looking at it right on the screen. But one thing that you should really do, this is important, you should memorize your squares from 1 to 12 at least. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. You should memorize those. You should just know those just like I did. Because a lot of times you're going to see a number like, say, 126, and you're going to think, oh, God, I wonder if there's a perfect square in there. And instead of having to sweat it out, you just take your calculator, and you take, let's erase this here. And you take 126, and you start dividing it by your perfect square. So you divide it by 4. Well, that didn't work. I don't get an even number. I take 126, and maybe I divide it by 16. No, that didn't work. Well, I'll take 126, and I'll divide it by 9. Oh, that worked. So now I know I can pull a 9 out from under that radical sign and just be left with the 14. If I don't know my perfect squares, that's going to be difficult to do. Let's take a look here at example D. I have radical 7 over 16. Well, that's equal to radical 7 over radical 16, which was nice for me to do because I knew that 16 is a perfect square. So that's going to give me radical 7 over 4. And that is the simplified form of this expression. So here are some problems from practice C. Let's just tackle one of them. Let's tackle this one. Let's look at it carefully. This is saying 2 times radical 32 times 3 times radical 21. We can remove the multiplication signs between the 2 and the 32 and the 3 and the radical 21, but it's the same thing. And since multiplication is commutative, I can change this to 2 times 3 times radical 32 times radical 21. Now I can simplify it a little bit more. 2 times 3 is 6. And that's times, well, what's 32 times 21? Let's go to my calculator. 32 times 21 is 672. Radical 672. Now, 672 is a big number. I think it's quite likely that that's going to be divisible by something that is a perfect square. So I'm going to try it. I have 672. I'm just going to start off with 4. So I'm going to divide by 4. And what do you know? I get 168. So I know that this is 6 times radical 4 times 168. But I'm looking at 168, I'm saying that's a pretty big number too. I wonder if that's divisible by something else. I'm going to try 4 again. Divide by 4. What do you know? 42. So it's equal to 6 radical 4 times 32. And what do I know about 32? I know something about 32. I know that 32 is divisible by 4 again. 42, sorry, my bad. Times 42. 42 is not divisible by 4. Is 42 divisible by 9? No, 42 is not divisible by 9. Is 42 divisible by 16? No, 42 is not divisible by 16. It's certainly not divisible by 25. So I can see that I have, I can make this into 6 times radical 4 times radical 4 times radical 42. So that is 6 times 2 times 2 times radical 42. So this is, what, 24 radical 42. And that's as simple as I can make this particular problem. Well, sometimes it's a little bit more difficult to simplify a term. And we're going to do this thing called rationalizing the denominator. We do not want a radical sign in a denominator. The reasons for that are actually kind of old-fashioned. Because, well, we'll show you at the end. There are 2 tricks to rationalizing the denominator of a fraction. So let's say I have the fraction 2 divided by radical 2. I don't want to have this radical 2 here in my denominator. I'm not allowed to have radical signs in the denominator. I have to get rid of it. Well, there's a way to get rid of a denominator. There's a way to get rid of a radical sign. I can multiply this by radical 2. If I multiply the radical by itself, then my denominator is going to be equal to 2. Right? Because the square root of 2 times the square root of 2 is the same thing as saying the square root of 2 squared, which is equal to 2. But if I multiply the denominator by radical 2, I also have to multiply the numerator by radical 2. What I do to the denominator, I have to do to the numerator. Because really what I'm doing is I'm multiplying my red fraction here by 1, radical 2 over radical 2. So we know that the denominator is equal to 2, and now the numerator is equal to 2 radical 2. And actually, I could even simplify this one even more by canceling out my 2's, because this is a product, and I would get the answer as radical 2. That might not have been like the greatest example. But let's try a different one. Let's say I have 4 over radical 5. I don't want radical 5 in my denominator. Don't want that. Round face. So I can multiply my numerator and my denominator by radical 5 divided by radical 5. I'm multiplying it by 1. And I can multiply anything by 1 and it's okay. So that's going to equal a fraction. I'm multiplying straight across. So my numerator is 4 radical 5. And my denominator is 5. I have now rationalized my denominator. I no longer have a radical sign in my denominator. And this is a perfectly acceptable answer. But let's say my denominator is a little bit more complicated. So I have 5 as my numerator, and I have 1 plus radical 2 as my denominator. So I have a sum in my denominator, a sum or a difference. Not a product. This is a addition sign. It is not a multiplication sign. So addition sign, this 1 and this radical 2 are really inseparable. Well, I can look at it and say, well, I'll just multiply both sides by radical 2. The top and the bottom by radical 2. And if I do that, let's put this in parentheses so we can see more clearly what we're going to get. We're going to get 5 radical 2 in my numerator, which is okay. But my denominator, I have to distribute this to both, is going to be radical 2 plus 2. Well, I haven't really succeeded in getting rid of the radical sign in my denominator. I'm still kind of stuck with it right here. I want to get rid of it. So what I'm going to do is this. I'm going to multiply my denominator. My denominator is 1 plus radical 2 by its conjugate. That's an important word. Conjugate. Conjugate. I'm going to conjugate it with its conjugate. Its conjugate is simply switching the plus or minus sign. So I'm going to multiply it by 1 minus radical 2. And let's see what happens when we FOIL this out. Well, my first term is 1 times 1. I get 1. My outer term is 1 minus radical 2. 1 times 1 minus radical 2. 1 times minus radical 2. That's negative radical 2. My inner term is radical 2 times 1. That's plus radical 2. Oh, this is getting exciting. And my last is radical 2 times negative radical 2, which is minus 2. Right? Radical 2 times negative radical 2 is the same thing as negative radical 2 times radical 2, negative radical 2, 2 times 2, negative 2. Make sure you're clear on the arithmetic here. But when I multiply a term, a sum like this, by its conjugate, the product is always a rational number. It is no longer a number with a radical sign. That is an irrational number. So what's happened here is my minus radical 2 goes away because it's offset by my plus radical 2. And I have 1 minus 2 is equal to negative 1. So let's do the problem now. My original fraction is 5 over 1 plus radical 2. I'm going to multiply that times the conjugate, 1 minus radical 2. But I have to multiply it by 1, which means I'm multiplying it by 1 minus radical 2 divided by 1 minus radical 2. Well, let's do my numerator first. I have 5 times 1, and then 5 times negative radical 2. That gives me 5 minus 5 radical 2. That's okay. Now I'm going to do my denominator. 1 times 1 is 1. 1 times negative radical 2 is negative radical 2. Radical 2 times 1 is positive radical 2. And radical 2 times negative radical 2 is negative 2. So this is equal to 5 minus 5 radical 2 divided by, those go away, 1 minus negative 2. 1 minus 2 is negative 1. So that is equal to, I could just call it negative 5 minus 5 radical 2, or I could call it negative 5 plus 5 radical 2, or I could call it 5 radical 2 minus 5. Convention is usually to put the whole number or integer or the non-radical number first, and then the number with the radical second. But this is an acceptable answer as well, because a lot of times people don't like starting expressions with a negative sign. So let's try one of these practice C problems, see if we can't get it right. This one is going to involve some extra steps, so we'll try and do it slowly and make sure that we understand how we're putting all these things together. So let's try this one, number 12. I'm going to rewrite it so we can have a lot of space. I have 4 plus radical 2, and I'm dividing that by 3 plus 2 radical 3. Well, I have this radical sign in my denominator, but it's part of a sum. So I need to rationalize it by using the conjugate. So I'm going to multiply my denominator by 3 minus 2 radical 3, the conjugate of 3 plus 2 radical 3. But I have to do it to my numerator too, so 3 minus 2 radical 3 and the numerator as well, because this is equal to 1. Well, let's work on the denominator first. And you know what I'm going to do is I'm going to make it a little bit easier, and I would recommend that you do this. If you just kind of do your work over to the side, do the numerator separate from the denominator so that you don't get too confused. So my denominator is going to be 3 plus 2 radical 3 times 3 minus 2 radical 3. All right, let's FOIL it out. First, 3 times 3 is 9. Outer, 3 times negative 2 radical 3 is negative 6 radical 3. Inner, 3 times 2 radical 3 is plus 6 radical 3. Are you noticing a pattern here? And last is 2 radical 3 times 2 radical 3. Well, let's kind of do that up here a little bit. 2 radical 3 times 2 radical 3 is 2 times 2 times radical 3 times radical 3, which is equal to 4 times 3, which is equal to 12. So that's going to be minus 12. Well, my negative 6 radical 3 and my positive 6 radical 3 cancel out. So I have 9 minus 12. I have negative 3. So my denominator is going to be negative 3. I'm happy with that. I'll just hold on to that for a minute. But now I have to do some work on my numerator. So my numerator, put a line here, is 4 plus radical 2 times 3 minus, let's make it a little bit neater, 4 plus radical 2 times 3 minus 2 radical 3. Well, that's going to be a little bit more complicated. But I can do it, and you can do it too. So, first is 4 times 3. 4 times 3 is 12. That one wasn't too bad. Outer. 4 times minus 2 radical 3 is negative 8 radical 3. Inner. 3 times radical 2 is plus 3 radical 2. And then last is radical 2 times negative 2 radical 3. Well, that's going to be minus 2 times radical 2 times radical 3. I want you to think about that one. Maybe pause the video here for a minute and see how that's true. All right, let's do some simplifying of this term. I have 12 minus 8 radical 3, can't do much there, plus 3 radical 2, can't do much there, minus 2 radical 6. I don't think I can do much with that at all. So I see my numerator as being that. Yes, it's a big ugly number, but it is what it is. So now I'm going to go back away from my scratch work. I'm going to go back to my problem, and I know what my numerator is. It is 12 minus 8 radical 3 plus 3 radical 2 minus 2 radical 6. And that's all divided by my denominator, which is negative 3. Perfectly fine answer. If you want to make it a little bit neater, you might want to move your negative sign away from the denominator and up to the numerator. So then I would have negative 12 plus 8 radical 3 minus 3 radical 2 plus 2 radical 6 divided by 3. And if you don't like having your numbers started by a negative sign, you could go 8 radical 3 minus 3 radical 2 plus 2 radical 6 minus 12. Again, over 3. Any one of those answers is going to be fine. As long as you get your numerator and your denominator correct and get the radical sign out of your denominator, you're going to be in good shape. So let's kind of move to using this information that we have about square roots now and use it to solve a quadratic equation. So here's a pretty straightforward example. I have the quadratic equation 3x squared plus 5 is equal to 41. Well, what I want to do is I want to end up getting x, because I'm solving it for x. I want to get x squared all by itself on one side of the equation and something else over on the left side, on the right side of the equation. Because that way, I'll be able to take the square root of both sides and wind up with just x equals some number over here. So I'm trying to isolate x, I'm trying to isolate x squared. Well, I can do that. With this one here, I'm just going to subtract 5 from both sides, and I get 3x squared is equal to 36. Now, that is not isolating x squared. That's still a 3 on there. So I'm going to divide both sides by 3, and I get x squared is equal to 12. Now, I'm going to take the square root of both sides. And here, don't forget, when you take the square root of a number, don't forget the plus or minus, right? If I have x squared is equal to 4, that means I take the square root of both sides. X is equal to the square root of 4 plus or minus, because the square root of 4 plus or minus can be 2 or minus 2. Either one of those, when I square it, is going to give me my radicand of 4. So don't forget your plus or minus sign. All right, so I have x is equal to plus or minus the square root of 12. I'm looking at 12. I'm thinking, what are my perfect squares that can go into 12? Oh, well, 4 is a perfect square that can go into 12. So I have x is equal to plus or minus the square root of 4 times the square root of 3. Or as I like to write it, I would go the square root of plus or minus, don't forget plus or minus, the square root of 4 times 3, and then I can change that into the square root of 4 times the square root of 3. So I have x plus or minus the square root of 4 times the square root of 3. That becomes 2. So my answer is x is equal to plus or minus 2 radical 3. Now, you only use this method if your quadratic does not have the middle term of x. For example, you would not use this method if you had 3x squared plus 4x plus 5. Can't use it because you'll end up moving your 4x to the other side of the equation and then back and forth. It's not going to help you. It's only going to help you if you do not have this middle term of a power of 1x. So I got my answer of 2 radical 3 and minus 2 radical 3. That's the same thing as plus or minus 2 radical 3. And so I have two answers. Plus or minus really indicates two separate answers. So I should go back to my original equation, and I should check the answers. So I'm going to say 2 radical 3 for x squared there, and I'm going to say negative 2 radical 3 for x squared there. I'm going to do the math, so let's just look at this line right here. I have 3 times 2 radical 3 squared plus 5. Let's take a closer look at 2 radical 3 squared. 2 radical 3 squared is equal to 2 squared times radical 3 squared. Just like, remember that when you have a product that is being squared, so for example, using an easier example, 2 times 5 squared, you're squaring all the terms inside the parentheses. So this would be 2 squared times 5 squared, 4 times 25, 100. The same thing as 10 squared, 2 times 5, which of course is 100. That is very different. It is very different from when you have a sum. If you have a sum 2 plus 5 squared, it is not equal to 2 squared plus 5 squared. That would give us 4 plus 25, which would give us 29. When in fact, this is equal to 7 squared, which of course is 49. So make sure that when you're doing this, you're remembering the difference between whether I have a sum or a product. So back to my problem here. 2 squared is 4. Radical 3 squared is 3. So this particular part of it is going to be 12. So I'm going to have 3 times 12 plus 5. I'll remember my PEMDAS. I'm going to remember, well, what goes first. So I'm going to have 36 plus 5. I'm going to have 41. And in fact, that was my answer. 41 is equal to 41. I could do the same check over on this side. But it's important to kind of walk you through the check here so you remember this particular thing here. Here's a good problem. It's a multiple choice problem, but it's a good problem nonetheless. The problem is 1/5. Instead of z, I'm going to use x, because my z's look like 2. Z plus 3 squared is equal to 7. So I'm solving this for x. Well, remember, I want to get my squared term all by itself on the left-hand side of the equation. It just so happens that my squared term isn't just a simple x, it's a sum x plus 3. It's okay, I can still do it. I'm going to multiply both sides of my equation by 5. Because I want to get rid of the 1/5 first. I'm going to begin to isolate my squared term. So that's going to go away, and I'm going to have x plus 3 squared is equal to 35. Well, I'm going to treat my x plus 3 just like it was an x all by itself. I have to liberate the x to solve for it. So I'm going to take the square root of this side, and if I take the square root of that side, I got to take the square root of the other side. Don't forget the plus or minus. So now I have x plus 3 all by itself is equal to plus or minus the square root of 35. And I don't think there's anything I can do with the square root of 35 to simplify it. It's not divisible by 4. It's not divisible by 9. It's not divisible by 16, and it's certainly not divisible by 25. So I'm going to leave it as it is under a radical sign. I want to now isolate my x, so I'm going to subtract 3 from both sides. What I'm going to wind up with is x equals negative 3 plus or minus the square root of 35. That's a perfectly good answer, but I don't see that as one of my choices. So I kind of have to remember that plus or minus means two different answers. So it's equal to negative 3 plus radical 35, and it's equal to negative 3 minus radical 35. Be very careful where you put your plus and minuses when you do plus and minuses. I go look at my multiple choice answers, and that is this answer right there. So I'm happy and I check it off, and I score an 800 on the SAT. No, I didn't score an 800 on the SAT, but I just threw that out there. So let's try one more problem here. I have 3 times x minus 1 squared equals 5/27. Practice C problem. I think we can do this one. Well, again, I have a difference right now, not a sum, but that is being squared, and I need to get rid of it. I need to get it isolated by itself. So what I'm going to do is I'm going to divide both sides of this equation by 3. Same thing as multiplying by 1/3. So I have x minus 1 squared is equal to, well, this is the same thing as multiplying by 1/3, is equal to 5 over 81. I think that's true. I'm going to double check. Yes, that's true. 3 times 27 is 81, which makes me really happy because I know that 81 is a perfect square, and since I'm dealing with square roots, it's going to make my life a little bit easier. So I'm going to take the square root of this side and the square root of this side to try and liberate my x. Don't forget your plus or minus. So I'm now left with x minus 1 is equal to the plus or minus the square root of 5 over 81, which is the same thing as plus or minus the square root of 5 over the square root of 81, which is the same thing as plus or minus the square root of 5 over 9. Isn't that nicer? That's much nicer. I still have this 1 sitting over here, though. It's kind of in my way. So I'm going to add 1 to both sides of the equation. And I get x is equal to 1 plus or minus the square root of 5 over 9. That's a perfectly fine answer. If you want to separate them into 2, it'd be 1 plus the square root of 5 over 9 and 1 minus the square root of 5 over 9. No need to do any additional simplification here. Now I'm going to be totally happy with that answer, 1 plus or minus, that's a 9 here, not a 2, sorry. Plus or minus 5 over the square root of 5 over 9. The book, the answer sheet gives a different answer. The answer sheet says, the answer is 9 plus or minus the square root of 5 over 9. You know, I think that's a little bit picky. And I'm not even picky, it's just different. But it's the exact same thing, because this is equal to 9 over 9 plus or minus the square root of 5 over 9, right? It just, I had a common denominator here. So it's the same thing as 1 plus or minus the square root of 5 over 9. So don't get freaked out if you look at the answers in the back of the worksheet and they come out a little bit different than yours. Look for things like this where really it's saying the exact same thing. I'm not going to take off if you write it like this as opposed to that. I will take off if you don't rationalize the denominator. No radical signs in the denominator. Okay, the last thing we're going to do here is just show how I can use this square root property to solve a word problem. So I'll read through this and explain it to you, but I'm solving a height problem, which are very common problems with a quadratic equation. So the equation is, and this is something that you will see, in physics, that height of a projectile being dropped is equal to negative 16 times t squared plus your original height. Well, t is time in seconds. And then your original height is your original height. So I would give you this equation. I would not expect you to memorize this equation. But it's saying, whoops, that's the solution. Let's find the problem here. It's saying in a science competition, you have to design a container that prevents an egg from breaking when dropped from a height of 50 feet. How long does the container take to hit the ground? That's where our time in seconds comes. And that's where this formula comes from. So this is our formula. This is the height. We know that the height when it lands is going to be 0, right? That's going to be splat. Maybe not splat, depends on how well you design your container. The original height is 50 feet. They gave that to us in the problem. So now I'm going to subtract 50 from both sides. So I have negative 50 equals negative 16t squared. I need to isolate my t squared, so I'm going to divide both sides by negative 16. So I get 50 over negative 16 is equal to t squared. And then when I take the square root of both sides of that, which I'm going to do right now, I'm not going to forget my plus or minus. So I'm going to get t is equal to plus or minus 50, the square root of 50 over 16. Well, in this case, they decided that they wanted it in decimals. So we just did the square root, which is second, and above x squared, we have the square root sign of 50 divided by 16. I put that in parentheses. And I have to end another parentheses because my square root sign on the calculator, you'll see, starts with the parentheses to find the argument of the square root. My argument of the square root is 50 divided by 16, which I had to put in parentheses. And then I close my parentheses, indicating that that whole value there is under the square root sign. I press enter, and I get 1.76. So they rounded it off to 1.8, and there's a plus or minus. But I cannot have negative time, at least not in this dimension. So my answer is just the positive 1.8 seconds. That's how long it's going to take to fall from 50 feet. That's a domain issue. The domain of this problem has to start at 0 seconds and go positive. I cannot go negative on my domain on this.